Hi guys, so today we'll be going through the generalized advantage estimation. So advantage estimation and short GAE. So before we go through the generalized advantage estimation, we have to understand what is that advantage. So the advantage of a given policy given a particular state and action is equal to the Q value minus the value. So what exactly this means? So in English terms, what the advantage is saying is how good is a current action versus the average of all its actions. And so Q measures how good a particular action is and V measures at a particular state how good are actions on average. Yeah, so we can see that when Q measures how good particular action is and V measures how good actions are on average, then the advantage is merely just Q minus V, which is shown by this equation. So now let's define it more formally, mathematically. So let's say we have some Q of some state and action, then this would be defined as the expectation, okay, and at time t, so this will be defined as the expectation of the reward at time t plus the discounted values of future rewards. So this is given a particular state and action. Yeah, so again, how good a particular action is measured by the rewards plus its discounted rewards. Now the value, so as we previously mentioned, it is at a particular state how good are the actions are on average. So there's no A here. So for the value, this is the expectation. So it's the same thing, the reward. So this measures how good the particular action is. So but it's an average over all the actions, so it's just at a particular state. So you can think of it as the value function is the expectation of all the actions sampled under some policy of the Q values. So given a particular state. Yeah, so now that we have a good understanding of what exactly is like the Q value, the value function, and the advantage, let's try to calculate what exactly is the general advantage estimation. So here we notice that the advantage is Q minus V, and for actually the Q function we can simplify it, so we use the Bellman equation. So if we use the Bellman equation, then Q would be the expectation of RT plus V yeah, so because if we were to, for example, like bracket this is effectively V as T plus 1. So this is so given some ST, so this is the Bellman equation. So what we can actually do is we can estimate the advantage. So now the advantage, yeah, but note that this is an expectation over all future states, so ST plus 1, which could be expensive to compute. So one of the ways that we can do this is to take a single sample or a sample estimate. So we can do a sample estimate of A, which will be, for example, if we take a single trajectory, it will be RT plus just the next state, if we take the action, minus the value function of the current state. So the advantage estimate would become this. And what we actually call this term is the temporal difference. Which we denote as this. Okay, so now we have used the Bellman equation to simplify it to the temporal difference equation, and this will help us to build up towards understanding the general advantage estimation. Okay, so let's clear this. Let's erase this. Yeah, so let's go back. Yep, so we showed that the advantage estimate is the temporal difference. Yeah, but for example, in the case of like LLMs, what if your value model is quite inaccurate? So what this could happen is we would get a very high bias. So the variance is low, but we get a very high bias because this is a very noisy estimate. So one of the things that we can do is, so for example, in the Q function is the estimate of RT plus, so this is the original Velma equation. But we can push our sample estimate further by taking more terms of RT. So what this means is that, so let's call this single step. It's just this. But let's say we want to take a two-step. Now instead of just taking reward at one time step, we will take the reward from the second time step as well. And then we'll add it by the value function of st plus 2. So actually we can actually decompose this even further. So let's show what this is actually equivalent to. So this is actually equivalent to RT plus gamma square so these two terms will cancel out, and plus, yeah, so what we actually get is just the temporal difference at time step t plus gamma, the temporal difference at time step t plus 1. And actually if we continue with A3, we get the same thing. So this is temporal difference plus gamma square and so on. Yeah, and so we get advantage infinity time step. So this would be the lowest bias but extremely high variance, because here we're still taking sample estimate. So yeah, you take the rewards for this sample, but this could lead to very high variance. So now we sum to infinity with L equals 0, and then it will just be the temporal difference of gamma L to the minus 1 T plus L. No minus 1, so just L T plus 1. So T plus L. So this is the advantage estimate, right? And so what exactly is the general advantage estimate? So how do we choose a good balance between like bias and variance? And it's hard to choose a single estimator. Do you take the one step, the two step? And it turns out that you can actually just take all, which is the general advantage estimate. So the GAE, we just take all. So this would be, and the way that we do this is through the weighted exponential average. So the weighted exponential average would be 1 minus lambda advantage at one step plus lambda advantage at two step plus lambda square advantage at 3 steps dot, 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 dot. Yeah, so let's see this. So previously we showed that advantage at time step t is equal to the sum of gamma times to the power of L times the temporal difference at time step t plus L. And we showed that instead of choosing a single time step, we can actually take a weighted average. So GAE equals to 1 minus lambda one plus lambda A2 plus lambda A3 and so on. So now we can try to derive it fully. So what this will be equivalent to is 1 minus lambda temporal difference at time step t plus lambda temporal difference at time step t plus gamma temporal difference t plus 1 and plus lambda square at t plus gamma temporal difference t plus 1 plus gamma square temporal plus 2 and so on. And what we see is that we can actually simplify this to 1 minus lambda temporal difference times t times 1 plus lambda plus lambda square dot plus no 1 plus, so just lambda square dot plus gamma square is t plus 1 t plus 2 lambda square plus lambda cube dot. And this is actually the geometric series, so what we actually get would be, if we sum it up, we get time step t times 1 over 1 minus lambda plus lambda over 1 minus lambda and so on. And this will actually cancel out the denominators. So what we finally end up with, so we can do this all the way to infinity, 0. So what we actually get is lambda gamma to the power of L of the temporal difference at time step t plus L. Yeah, and this is actually the formula used for general advantage estimation. Yeah, hope you all enjoyed this derivation, and we'll continue with more whiteboarding sessions.